So Proton NMR. So like, what do we use NMR for? Basically, in a lab, people want to find the structure of a unknown molecule. So they put this molecule in this like specific solution, which we're gonna talk about later, and put it in the machine and have and apply electromagnetic radiation to the molecules. And the molecule's nuclei is gonna absorb it, and then it's gonna give off a unique spectrum to that molecule. And the spectrum is like the graph with the lines that we get, and from the spectrum we're going to try to guess, and of course the existing knowledge we have, we're going to try to guess what structure of that molecule is. We're not going to have to read the graph later. What happens when the electromagnetic radiation hits the nuclei? It turns out that the nuclei itself has its own magnetic fields. So, the magnetic fields in the natural magnetic fields in each nuclei are different, and they have their spin states, and such spin states can affected by a external magnetic field, such as the one that the machine we use to apply. So when the spin state of the nuclei aligns with the external magnetic field, then we call it alpha. And when the natural spin state of the molecule against the external magnetic field, then we call it beta. So I don't really understand anything other than what I just said about alpha and beta. And if you want to learn more about it, I guess you're on your own or have to look up more information. So should I do it next? Oh, okay. So more about the spin states. So like I said, different nuclei like absorbs the electromagnetic radiation like differently. And what happened is that like our goal is to like apply electromagnetic radiation so that its nuclei start to spin in the alpha or beta state. But then because each nuclei have different amounts of energy, which means the amount of electromagnetic radiation that we need to make it spin, it's different. And how are these spin states gets affected by the local magnetic fields? So the local magnetic fields could be affected other than the external NMR that we're applying. It could get affected by like the lone pair electrons, or like electrons from like the neighboring nuclei. All these like factors gonna be altering the strength that's needed to make the nuclei to spin. And next, so basically, let's say we have a molecule of methyl, like CH3. So the carbon has a nuclei and the hydrogen has a nuclei. And proton NMR, just I guess you already know, is is what we're doing. We're reading the hydrogen nuclei spin state. Like I said, like the molecule has to be put into a special solution, and this solution is made up largely of tetramethylcycline, which has a formula of CH3, 4, and Si, silicon. And the reason why we use this molecule is that if you were to draw it out, and all of the protons of this molecule absorbs the same value. And as we go on later, you will understand why does the protons of this molecule all absorbs the same amount of energy. It's not loading. Okay, I guess that's it for this video, and then I'm gonna do another one right after this.